This video will cover how to estimate one-way analysis of variance models using R. The basic framework for one-way analysis of variance, or just ANOVA, is that you have a dependent variable that's interval ratio and coded as numeric, and then you have an independent variable that's categorical and has at least 3 categories attached to it. The data that I'll be using to fit this model, just like always, is going to be the 2016 wave of the General Social Survey. The 2 specific variables that I'm going to be working with, on the dependent side, I'm going to be using occupational prestige for the respondent, and then for my categorical grouping variable, I'm going to be using the variable happy, which is just a variable measuring the respondent's level of happiness with 3 different categories from it. The basic command that you need to fit a ANOVA model is AOV for analysis of variance. Then you just open up brackets, you put your Y, so here it'll just be pressed G10, and then you use the tilde for given, and then you put your grouping variable, so happy. The other thing that you'll want to include is just the optional argument data and then the name of your data frame object. And so for me, I named the GSS, so you could just put it in here. You could equivalently rewrite this code, dropping the optional argument, and then just put GSS $sign for both happy and for prestige, and that'll produce an equivalent result. Anyway, now that we've set up the core formula that we're going to be using, you could just run that line, and you'll see that R will return some results, but it's probably not what you're expecting. So it gives you your sums of squares, and it gives you your degrees of freedom. So it starts with the sum of squares between and degrees of freedom between, and then what R calls the sum of squares residual, or you might have heard that called the sum of squares within, on the second column there. This is all that you need to actually go through and get your F statistic and make a determination of statistical significance and substantive significance. But it's a much better approach to actually create a model object that you use, that you assign based on the results of the AOV command. And so here I've just created M1, which for model 1, and you'll see that in my global environment over here, I have a new object popping up called M1. The next thing that you'll want to do to actually get the results in the format that you're probably expecting is use the summary command on the model object. So just type summary, open up some parentheses, and then type M1. And then if you run that, you'll see that it gives you the result that you were probably expecting. So just like before, you get your degrees of freedom for between, which is the first row that I'm highlighting, and then within is the second right there. And so you get your sum of squares, your mean squares, and then finally you see your F statistic, which has 2 and 2,741 degrees of freedom. And so you could go and look that up in the table in the back of the book, or you could just glance at the p-value, which you would compare to your alpha value. So here we would just conclude that there are statistically significant differences in occupational prestige by happiness level.